If x is a positive real number such that x power 8 plus 1 by x power 8 is 47, then the value of x power 9 plus 1 by x power 9. Standard question, nothing dramatic about this. X power 8 plus x power 1 by 8, 1 by x power 8. It all depends on this one funda. When you use a different variable, y plus 1 by y, the whole square is y square plus 1 by y square plus 2 into y into 1 by y. So we have y plus 1 by y, we can get y square plus 1 by y square. Y square plus 1 by y square, we can get y power 4 plus 1 by y power 4. And then one step more is this. We've got that. How do we go to this? What's happening here? And so suppose we have y plus 1 by y whole cube. This is y cube plus 1 by y cube plus 3 times y into 1 by y into y plus 1 by y. Nice. So we have this and this, we've got this. So this is the method. So you can do the same thing for y minus 1 by y whole square. Y minus 1 by y whole square is y square plus 1 by y square minus 2. So the whole funda is we're just going to use this to carve this entire thing open. So let's go step by step. After we crack the method, it's a painful question because very time consuming. Right? So let's go step by step and say, hey, x power 4 plus 1 by x power 4 whole square is x power 8 plus 1 by x power 8 plus 2. 47 plus 2 is 49. X power 4 plus 1 by x power 4 is therefore 7 because it cannot be negative. 7 square. Done. So far so good. So now we say, hey, nice. So x square plus 1 by x square, the whole square, is x power 4 plus 1 by x power 4 plus 2. Remember, we got this as 7. 7 square is 49. 47 plus 2. So 7 plus 2 is 9. X square plus 1 by x square could be 3 or minus 3. It's x square plus 1 by x square. It cannot really be minus 3. Therefore, x square plus 1 by x square is 3. 3 square is 7 plus 2. So far so good. Also x is a positive real number. I had completely forgotten that, but doesn't matter. So far so good. So x plus 1 by x whole square is x square plus 1 by x square plus 2. X plus 1 by x whole square is 3 plus 2 5, or x plus 1 by x is root 5. So x plus 1 by x is root 5. Nice, beautiful. So we take x plus 1 by x, the whole cube, x cube plus 1 by x cube plus 3 times x plus 1 by x. 3x into 1 by x, x plus 1 by x, this is root 5, root 5 cube, root 5 into root 5 into root 5, 5 root 5 equals x cube plus 1 by x cube plus 3 root 5, or x cube plus 1 by x cube is 2 root 5. Plug that back in here. X cube plus 1 by x cube whole cube is x power 9 plus 1 by x power 9 plus 3 times x cube plus 1 by x cube. This is 2 root 5, 2 root 5 the whole cube. So 2 root 5 into 2 root 5 into 2 root 5, 2 root 5 into 2 root 5 is 2 into 4, 4 into 5 20, 20 into 2 root 5, which is 40 root 5 equals, this is what we need to find, plus 3 times 2 root 5. 3 times 2 root 5 is 6 root 5, 40 root 5 is something plus 6 root 5, or this something is 34 root 5. Hopefully that's there among our choices. Yes, it is there. That is the right answer. Now, once you know that we are manipulating x plus 1 by x, x square plus 1 by x square, x power 4 plus 1 by x power 4, going from x plus 1 by x to x cube plus 1 by x cube, we know that framework. Then this is doable. Still a pain, still time consuming, because you go from power 8 to 4 to 1, 1, 3, 9. So x power 8 to x power 4 to x square to x1, 3 steps, 3, 9, 2 more steps here, 5 steps of manipulating to get here. So it's a painful question even after we crack the method straight away. Let n and m be two positive integers such that there are exactly 41 integers greater than 8 power m and less than 8 power n, right? Which can be expressed as powers of 2. Okay, nice. So 8 power m greater than 8 power m and less than 8 power n. So 41 integers that can be expressed as powers of 2. Fine. So this is 2 power something, 41 different values. Nice. Then the smallest possible value of n plus m is nice. So 8 power m and 8 power m, 8 power n. In between these two, bunch of powers of 2 are sitting there. Right? First of all, this is 2 power 3m less than 2 power something less than 2 power 3n. So between 3m and 3n, between say 9 and 36, and some 2 values. Fine. So 3m and 3n, how many different values can there be? So let's say we're looking at numbers from say 2 power 9 less than 2 power something less than 2 power 21. How many values can n take? 10, 11, 12 till 21. 21 minus 9 is 12. There can be 12 different values. There can be 11 different values. Nice. So it's very important adjustment, because otherwise this 41 won't come. When I did this question, I did 3n minus 3m and say 3 times n minus m. How is it going to be 41? It's not 3 times n minus m. It is 3n minus 3m minus 1, because it is in between. It's greater than this and less than that. So now we get quite beautifully 3n minus 3m minus 1 equals 41, or 3 times n minus m is 42, n minus m is 14. What are the smallest values of m plus n? N minus m is 14. All we need to m and 2 be two positive integers. So m could be 1, m is 1, in which case n is 15, 1 plus 15, 16. Done. Once we find the difference, plugging it in is far simpler. Doable question. For some real numbers a and b, the system of equations x plus y equal to 4 and a plus 5 times x plus b square minus 15 times y equal to 8b has infinitely many solutions for x and y. And then the maximum possible value of ab is, fine. So super peeved with this question because I skipped it in the end, because I didn't even understand this question. Fine. So x plus y equal to 4, a plus 5 times x plus b square minus 15 times y equal to 8b. This has infinitely many solutions. Infinitely many solutions for x and y. a1 by a2 equal to b1 by b2 equal to c1 by c2. Plug that in, we should get somewhere. So we get a, I'm going to divide this by this. A plus 5 by 1 equals b square minus 15 by 1 equals 8b by 4, just 2b. b square minus 15 equal to 2b minus 2b equal to 0. So b square minus 2b minus 15 is 0. So b minus 5 into b plus 3 equal to 0. So b is either 5 or minus 3. A plus 5 equal to 2b. B is 5 or minus 3. So a plus 5 is 10, in which case a is 5. A plus 5 is minus 6, in which case a is minus 6 minus 5 minus 11. A is 5 if and b is also 5. A is minus 11 if b is minus 3. What is the maximum possible value of AB? Either 5 into 5, 25, or minus 11 into minus 3, 33. 33 is larger, answer is 33. Once we plug in a1 by a2 equal to b1 by b2 equal to c1 by c2, we're through. My brain was so scrambled even by the time there was a third or fourth question, because I'd seen too many x and y. I didn't even pick that. I just had to skip this question and carry on. I should have come back to it, didn't pick it second time around either. For real number x, if 1 by 2 log to the base 3 of 2 power x minus 9 by log to the base 3 of 4, log to the base 5 of 2 power x plus 17 by 2 by log to the base 5 of 4 are an arithmetic progression. First of all, log a to the base b by log c to the base b is log a to the base c. And so I'm going to simplify this and say the terms are 1 by 2, log 2 power x minus 9 to the base 4, log 2 power x plus 17 by 2 to the base 4. They are in arithmetic progression. That means this plus this equals 2 times this. So half, I'm going to write this as log 2 to the base 4, that is half, log 2 to the base 4, which is half, plus log 2 power x plus 17 by 2 to the base 4 equals 2 times log of 2 power x minus 9 to the base 4. So, like 2 power x minus 9, 2 power x minus 9 to the base 4. So, this plus this, I'm going to put a bracket around this because it's very confusing, is equal to that. Now, this becomes a far simpler question. So, because 2 into 2 power x plus 17 by 2 equals 2 power x minus 9 the whole square. 2 into 2 power x plus 17 by 2 equals 2 power x minus 9 the whole square. I'm going to call 2 power x as y. So, this is y minus 9 the whole square. 2y plus 17 equals y minus 9 the whole square. 2y plus 17 is y square minus 18y plus 81. So, y square minus 20y, 81 minus 17 is 64. So, this is y minus 4 into y minus 16 equal to 0. Y is 4 or 16. So, 2 power x is y. So, 2 power x equal to 4 or 16, or x could be 2 or 4 plus or minus, not plus or minus, either 2 or 4, no plus or minus, sorry. If x were 2, 2 power x would be 4, 4 minus 9 is a negative number, I don't have to worry about it, I shouldn't be worrying about it, therefore 2 is not possible, so x has to be 4. Because 2 power x minus 9 has to be positive, 2 power x plus 17 by 2 has to be positive. Therefore, we know that x is 4. So, now we need to find the common difference. Let's do this. Half log of 2 power 4 is 16, 16 minus 9, 7 to the base 3 by log 4 to the base 3, whatever this is. I don't even have to find the third term because I want to find a common difference. I'm going to do this minus this. So, half, log 7 to the base 4. This I can write it as log 2 to the base 4. This minus this is a common difference. So, log 7 to the base 4 minus log 2 to the base 4, which is log of 7 by 2 to the base 4. That is a common difference. This is 7, even though it looks weird. 7 by 2 to the base 4 is a common difference. Hopefully, that's among the choices. Indeed, it is. That's about the first two natural numbers, each having 15 factors, including 1 and the number itself. 15 factors, a number of the form p power a into q power b has a plus 1 into b plus 1 factors. 15 can be written as 3 into 5 or just 15 alone. So, we're looking for a number of the form p power 4 into q square or number of the form p power 14. First two natural numbers, each having 15 factors, including 1 and the number itself, which is nice. So, p power 4 into q square, the smallest number is 2 power 4 into 3 square. This is 2 power 14, which is huge, small. And so, the smallest number, the next smallest number is either 3 power 4 into 2 square or 2 power 4 into 5 square. This is the smallest. Both these are smaller than this. This is out. So, smallest number is 2 power 4 into 3 square, 16 into 9, 144. This 3 power 4 into 2 square is 81 into 4, 324. 2 power 4 into 5 square, 2 square into 5 square is 100. Another 2 square, this is 400. This is 20 square, 400. This is too great. So, 144 and 324 are the first two numbers. So, we have to find the sum of the two numbers. Oopsie. 144 plus 324, which is 468. That's the number we are looking for. 468 should be among the choices. Oh, this is theta, this is fine. Let n be any natural number such that 5 power n minus 1 is less than 3 power n plus 1. Then the least integer value that satisfies 3 power n plus 1 less than 2 power n plus m for each n. And so it's one of those beautiful questions. I got caught out by this. Beautiful because it looks severely algebraic. There's an n and an m and then there are powers and all that. 5 power n minus 1 less than 3 power n plus 1. And so that's not algebraic at all. It's just numbers, nothing more than that. What I'm going to do, let me say n equal to 1. I'm going to think about 5 power n minus 1. I'm going to think about 3 power n plus 1. And so 5 power 0 is 1, 3 square is 9. I'm going to write powers of 5. 1, 5, 25, 125, 625 and so on. 9, 27, 81, 243, 729 and so on. 5 power n minus 1, 3 power n plus 1. Each term is the previous number into 5. Each one is previous number into 3. This starts off bigger than this. Somewhere this fellow is going to catch up. I'm multiplying by 5. I get bigger and bigger and bigger. Sooner than if this is multiplied by 3. This question hinges on where does this sequence overtake this sequence. That's it. That's a starting point. We grab onto that, we get through that much quicker. I put n equal to 1. Didn't work. This is lesser. Lesser, 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 lesser. But the moment we come here, you can even sense that this is going to work. 625, 729 is very close. I multiply this by 3. I don't even have to find the number. It is some 2187. I don't care. This is greater than this. N equal to 1, 2, 3, 4, 5, 6. From 6 onwards, 5 power n minus 1 is greater than 3 power n plus 1. And so till 5, this holds good. 5 power n minus 1 less than 3 power n plus 1. N could be 1, 2, 3, 4 or 5. One of these. Right? 1, 2, 3, 4, 5 all works. From 6 onwards, 5 power 4 is greater than 3 power 6. This fellow overtakes. We know that 5 power n minus 1 is less than 3 power n plus 1. N is 1, 2, 3, 4 or 5. Now come to the second part. The least integer of m that satisfies 3 power n plus 1 less than 2 power n plus m. Right? Nice. So n could be 1, 3 square less than 2 power m plus 1. N could be 2, 3 cube less than 2 power m plus 2. We want to find the least integer value of m that satisfies this. So we have to find the least value of m here, 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 all the way till n equal to 6. 3 power 6 less than 2 power m plus 6. Okay. 3 square 9, 9 less than 2 power m plus 1, 9 less than 16. For this case, m is 3, 2 power 4. 3 cube is 27, it should be 32, m plus 2 is 32, m plus 2 is 5, m is 3. Straight away I sense that, look, I don't need to do every number, I'll go here. And 3 power 6 is 3 square whole cube, 9 cube, 729 less than 2 power 10, m plus 6 is 10, m is equal to 4. Somewhere it goes from 3 to 4, it is 3 or 4. I can kind of figure that out, I can guesstimate that because I'm going to have 3 power 4 less than 2 power m plus 2, 81, the next number is 128, 128 is, 3 power m plus 3, 128 is 2 power 7, m is 4, right? So 3 power 6 is 729 less than 2 power 10, this is n plus m, m is 5, it should be m plus 5, it's not 4, m is 5. Sorry about that. So the value of m that satisfies this for all such n is the smallest possible value for everything should be at least 5. The answer, the least value m can take is 5. It's a beautiful question because there is practically nothing that we solve algebraically in this question. We're not solving a quadratic, we're not solving a cubic, we're not solving some exponents and logarithm, fancy stuff, nothing. We basically look at this question and go, let me substitute lots of values, see where this falls in place. And beautiful question because of that. Anil mixes cocoa with sugar in the ratio 3:2 to prepare mixture A. So cocoa with sugar 3:2. and coffee with sugar in the ratio 7:3. So sugar and coffee 7:3. So 3:7. This is mixture A, this is mixture B. Right. He combines mixtures A and B in the ratio 2:3. So the total number of units here is 5. Total number of units here is 10. Mixing in the ratio 2:3. So 3 plus 7, 10. I need to make this a multiple of 3. In which case that will go to 30. That goes to 30. This should be 20. Yeah, I can figure out 20 with this. So I'm going to translate these and call this 3:7 as 9:21. Adding up to 30. This should add up to 20. So this becomes 12:8. 12 plus 8 is 20. 9 plus 21 is 30. This is totally 30 units, this is totally 20 units. So the overall mixtures in the ratio 2:3. The 3:2, 3:7 are maintained. Mixtures in the ratio 2:3 to make a new mixture C. So our man C will have 12 units of coffee, 17 units of sugar, and 12 units of cocoa, 17 units of sugar, and 21 units of coffee. If he mixes C with an equal amount of milk to make a drink, then the percentage of sugar in this drink will be, he's mixing these three in the ratio 12:17:21, 12 plus 17, 29, plus 21, 50. Equal amount of milk, that means the milk quantity is 50. Total is therefore 100. Nice. The percentage of sugar in this drink will be 17 by 100, which is 17%. Nice, doable question. The population of a town in 2020 was 100,000. The population decreased by Y% from the year 2020 to 2021 and increased by X% from 21 to 22. So 2020 was 1 lakh. Down by Y% to 2021, up by X% in 2022. Where X and Y are two natural numbers, the population in 2022 was greater than the population in 2020 and the difference between X and Y is 10. Then what is the lowest possible population of the town in 2021? This is greater than this. So we take 2020, decrease it by some percentage, increase it by a higher percentage because the base is lower, so the total goes higher. So if Y were say 15, X will have to be 25. 100,000 into 85 or 0.85 into 1.25 should be more than 100,000. That's what we're looking at. And so we're solving for 100,000 into 1 minus Y by 100 into 1 plus X by 100 to be greater than 100,000. And so 1 minus Y by 100 into 1 plus X by 100 should be greater than 1. We know additionally the difference between X and Y is 10. Beautiful question. But shouldn't do all that, should look at these numbers. So the population in 2021 is 74,000, then it is down 26%. So we do 74,000 into 1.36 and see if that's greater than 100,000. Up, or we take 75,000 into 1.35, 73,000 into 1.37, down 25, down 27, or 72,000 into 1.38. The number should be more than 1 lakh and it should be as close to 1 lakh as possible. I know this beautiful fact, which is a wonderful fact, that is 137 into 73 is 10,001. So I can look at this question and go, hey, this is very nice. Otherwise, we just substitute this, punch it to the calculator. If that's the answer, this is the number. Kind of question where we don't do algebraically, where we shouldn't be saying 1 minus Y by 100 into 1 plus X by 100 is greater than 1. And we know X is Y plus 10, find the least possible value. We're not doing that. The 3 persons A, B and C in a room, for person D joins the room, the average weight of the person in the room reduces by X kilograms. A, B, C, D enters, average falls by X kilograms. If person E joins the room, The average weight of the person in the room increases by 2x kilogram. E enters. Average increases by 2x kilogram. So D is bringing in less than the average of A, B and C. E is bringing more than the average of A, B and C. Instead of D, E comes. D is not already sitting there. A, B, C, D or A, B, C, E. The average weight of the person in the room increases by 2x kilograms. The weight of E is 12 kgs more than that of D. Nice simple question. So we have A, B, C, D averages minus x from whatever it was. A, B, C, E averages 2x plus 2x from whatever it was. So if I think about this, I have A, B, C, D and A, B, C, E. The average difference between these two is 3x. Original average was somewhere here. This is minus x, this is plus 2x. Instead of D, I bring in E, the average goes up by 3x. I can think of it like that. Average is up by 3x over 4 people, or the total is up by 12x, 3x into 4. Average weight, the weight of E is 12 kilograms more than D. E brings in 12 kgs more than D. 12 kgs extra is 12x, x is 1. Just romp home instead of making it too algebraic and putting x and y and all that. Just look at this question and say, hey, nice, 2x up instead of x down, 3x as the average change. Total change is 12x, 12x is 12x is 1 done through. A merchant purchases a cloth at a rate of rupees 100 per meter and receives 5 centimeter length of cloth free for every 100 centimeters that he buys. He sells the same cloth at a rate of 110 per meter but cheats his customers by giving 95 centimeters length of cloth for every 100 centimeters length. It's cost price. This, he buys 100 per meter but he gets 5 centimeters extra. Cost price per meter, rupees 100 by 1.05. Selling price per meter is rupees 110.95. He sells at 10 rupees more, rational price wise, he cheats, gives them only 0.95. If the merchant provides a 5% discount, the resulting profit, he gives a 5% discount. This is the listed selling price. Actual selling price is this into 0.95, which is really nice because this goes away. So the profit made by him, we have cost price, we have selling price, find profit. Selling price by cost price into 100, we'll get that equation. So 110 by 100 into 1.05. 110 into 1.05 by 100, 1.1 into 1.05 minus 1. This is 10%, that is 5%. Multiply that, will be little more than 15%. I am very willing to gamble and put this in. Our answer is 1.1 into 1.05 minus 1. How would I get this number? I am doing just selling price by cost price. I don't want to do selling price minus cost price is P by CP into 100. I just want to do selling price by cost price. It will be 1 point something because he's making profit. That something is profit percentage. So 110 by 1.05 or 110 by 100 into 1.05, 1.1 into 1.05. This is 10% higher, that is 5% higher. I multiply both of this, it will be more than 15% higher. Little more than 15, this answer I am going for it. If I have a calculator, I am punching it in and getting, otherwise I am just plonking it. 15.5%. The number of coins collected per week by 2 coin collectors A and B are in the ratio 3:4. So A and B 3:4 coins. The total number of coins collected by A in 5 weeks is a multiple of 7. So this is coins per week. 5 weeks is a multiple of 7. Then the total number of coins collected by B in 3 weeks is a multiple of 24. So in 5 weeks, let's say this is 3x and 4x, we'll collect 15x, and 3 weeks the number of collected is 4x into 3, which is 12x. then the minimum possible number of coins collected by A in 1 week. So it's 15x is a multiple of 7, so x has to be a multiple of 7. 12x is a multiple of 24, there's already 12 sitting in there, x has to be a multiple of 2, x has to bring in 2. So 2 and 7, x has to be a multiple of 14, so I'm going to simplify this. Let's say A and B, x, 3 into x is 42, 4 into x is 56. This is 42k and 56k. So the minimum A can bring in 1 week is 42 when k is 1. What are we doing here? We're basically saying 15x is a multiple of 7, x is a multiple of 7. 12x is a multiple of 24, x is a multiple of 2. X is a multiple of 7 and a multiple of 2, x has to be a multiple of 14. So x can be written as 14k, 3x is 42k, 4x is 56k. What is the minimum number? 42k minimum can be 42 when k is 1. And that's what we're doing here. A quadratic equation x square plus bx plus c equal to 0 has two real roots. The difference between the reciprocals of the roots is 1 by 3 and sum of the reciprocals of the squares of the roots is 5 by 9. Then the largest possible value of b plus c. Incredibly complicated question. We have the roots to be alpha and beta. We know alpha plus beta is minus b. Alpha beta is c. Sum of the roots is minus b by a. Product of the roots is c by a. A is 1. We've got this. Right? So, if alpha and beta are not comfortable with, call it p and q. Right? So let's not go all Greek and Latin. I've started with this, so I'm going to continue with that. Difference between the reciprocals of the root is 1 by 3. 1 by alpha minus 1 by beta is 1 by 3. Or 1 by beta minus 1 by alpha, it doesn't matter. The sum of the reciprocals of the square of the roots is 5 by 9. 1 by alpha square plus 1 by beta square is 5 by 9. 1 by alpha square plus 1 by beta square is 5 by 9. I can work with this better because this can be simplified in these terms. So this becomes alpha plus beta, the alpha square plus beta square by alpha square beta square is 5 by 9. Is alpha plus beta the whole square minus 2 alpha beta. Alpha plus beta the whole square minus 2 alpha beta by alpha square beta square is 5 by 9. Is b square minus 2c by c square. B square minus 2c by c square is 5 by 9. Right, so we've got alpha plus beta the whole square. If you think about alpha minus beta the whole square, this is alpha square plus beta square minus 2 alpha beta, or this is alpha minus alpha plus beta the whole square minus 4 alpha beta. So alpha minus beta the whole square is b square minus 4c. Right. So we have 1 by alpha minus 1 by beta, it is beta minus alpha by alpha beta is 1 by 3, or beta square minus beta minus alpha the whole square by alpha square beta square is 1 by 9. Why am I going towards beta minus alpha the whole square? That's what I can get. Like, no, I can get alpha plus beta the whole square, alpha minus beta the whole square, because alpha square plus beta square, alpha square plus beta square minus 2 alpha beta plus 2 alpha beta, all of the manipulations I can do. So I've got alpha plus beta and alpha beta. So I can get alpha square plus beta square, alpha minus beta the whole square. I have an alpha minus beta here, I square that. So if alpha minus beta the whole square or beta minus alpha the whole square, both are same. So we have beta minus alpha the whole square, that is b square minus 4c by c square to be 1 by 9. B square minus 2c by c square is 5 by 9. B square minus 4c by c square is 1 by 9. I can subtract one from the other. The b square term will disappear. So I have b square minus 2c minus b square plus 4c by c square, or I have 2c by c square to be equal to 4 by 9. I am subtracting from 1, I am subtracting 2. B square minus 2c minus of b square minus 4c by c square. B square disappears, 2c remains, 2c by c square is 4 by 9. This goes away, 2 by 9, this goes away. 1 by c is 2 by 9, or c is 9 by 2. I've got c equals 9 by 2. Then what do I have? I can substitute in either equation, b square minus 2c by c square b square minus 2c by c square equals 5 by 9. This is c square, I multiply this by c square, b square minus 2c is this into 9 by 2 into 9 by 2. B square minus 9 equals 5 into 9, 45 by 4, or b square equals 45 by 4 plus 36 by 4, which is 81 by 4, or b is plus or minus 9 by 2, either 9 by 2 or minus 9 by 2, one of the two. So c is 9 by 2, b is plus or minus 9 by 2. Want the largest possible value of b plus c, 9 by 2 plus 9 by 2, just 9. Right? So I have a feeling that there could be some juicier manipulation of this. I'm yet to come upon it, but I know that it is not too simple. It's too much simpler than this. It's a pain in the neck. It's a round goose, kind of proper wild goose chase to isolate each of these and find that classic tough question. Simple framework of quadratic equation, but super difficult as a question. A boat takes 2 hours to travel downstream a river from port A to port B and 3 hours to return to port A. Oopsie. So A to B, this is downstream, this is 2 hours, coming up is 3 hours. Right, so another boat takes a total of 6 hours to travel from port B to port A and return to port B. The speeds of the boats in the river are constant and the time in hours taken by the slower boat to travel from port A to port B is nice. 2 hours, 3 hours. Time taken is 2 hours to 3 hours. Speed ratio should be the other way around. So downstream speed to upstream speed. Sorry. Speed downstream is to speed upstream. It's 3:2. I can imagine 3:2 as 6:4. Then I can think of this as 5 plus 1 is to 5 minus 1. Or where am I heading with all of this? We know downstream speed is boat speed plus stream speed. Upstream speed is boat stream minus stream speed. So B plus S is 6, B minus S is 4, or boat stream is 5, speed is 5, stream speed is 1. I'm not saying they're 5 and 1, ratio of 5:1. Right? So I'm going to say speed of boat 1 is 5k, speed of stream is k. So 5k plus k is 6k, 5k minus k is 4k, ratio is 6:4, 3:2, time taken should be in the ratio 2:3. Right? The distance between these two is where d, then we are told d by 5k plus k, d by 5k minus k. These are the times taken. This is 2 hours, this is 3 hours. 5k minus k, I have written 5k minus 5. Right? So 6k, d by 6k is 2 hours, or d is equal to 12k. 12k by 6k is 2 hours, 12k by 4k is 3 hours. And so now we've got speed of boat 1 to be 5k, stream to be k, distance to be 12k. Right? So far so good. So that it nicely works to be 2 hours, and this is in kilometers per hour, that is in kilometers, everything works out, the units cancel out, all of that. What do we need to find? We need to find speed of boat 2. Not just that, we need to find the time taken in hours taken by the slower boat, which is boat 2, because boat 2 takes a total of 6 hours to travel from A to B, to travel downstream. So what have we got to do? We've got to say d by boat 2 plus stream plus d by boat 2 minus stream is equal to 6. And then solve for boat 2, and then the answer is time taken to go downstream, or the shorter time. This one is our answer. And so let's fill this in. 12k by b2 plus k plus 12k by b2 minus k is equal to 6. And then find b2 in terms of k and then simplify and solve. So there are two variables in this equation, but it's actually, technically speaking, only one ratio. which is k, divide by k throughout. 12 by b2 by k plus 1 plus 12 by b2 by k minus 1 is equal to 6. Let's say b2 by k, we call it as x. 12 by x plus 1 plus 12 by x minus 1 is equal to 6. This is 2, I'm going to call it 1 by 2. So x minus 1 plus x plus 1 by x square minus 1 equal to 1 by 2. 2x, 4x, so 4x equals x square minus 1. X square minus 4x minus 1 equal to 0. X square minus 4x plus 4 is equal to 5. We solve this, we can get x. So x square minus 4x plus 4 equal to 5, or x minus 2 the whole square is 5. X minus 2 is plus or minus root 5. X is 2 plus or minus root 5. It cannot be 2 minus root 5. It will become negative. We are talking about a nice ratio. It will be 2 plus root 5. Oops, I erased that. X is 2 plus root 5. Now we come back to this. The time taken here, this is 12 by x minus 1. This is 12 by x plus 1. We are talking about time taken to go downstream. Slower boat to travel from A to B. Should be the shorter time, should be this 12 by x plus 1. I'm going to substitute that. We're going to talk about 12 by 2 plus root 5 plus 1. 12 by 3 plus root 5. Okay. So 12 by 3 plus root 5, 12 into 3 minus root 5 by 3 plus root 5 into 3 minus root 5. 3 plus root 5 into 3 minus root 5 is 9 minus 5, 4. 12 by 4 is 3. 3 times 3 minus root 5 is the answer. Looks like a speed time distance question, but some upstream downstream thing, but it's anything but. It's a deep rooted quadratic equations question. We have to be very careful about every ratio, simplification, all of that. And once again, really tough question. A fruit seller has a stack of mangoes, bananas and apples with at least one fruit of each type. At the beginning of a day, the number of mangoes make up 40% of his stock. Okay. That day, he sells half the mangoes. So 40% of his stock is mangoes. So let's say he has mangoes, bananas, apples and total. If total is 5x, he has 2x mangoes. That day he sells half the mangoes. So he sells x 96 bananas and 40% of the apples. Let's say apples is A, 0.4A. At the end of the day, he ends up selling 50% of the fruits. So this number is 50% of 5x. Nice. So x plus 96 plus 0.4a is 50% of 5x. It's the smallest possible total number of fruits in the stock. Okay, nice. So x plus 96 plus 0.4a, he's selling half of this. He's selling 40% of this. So this number should be more than 50%, and that much we know. And so x plus 96 plus 0.4a is 2.5x, and so 96 plus 2 by 5a is 3 by 2x. So I'm going to multiply by 10 throughout, so in order to eliminate the pesky 5 and 2. So 960 plus 4a equals 15x. Now if you want to find some integer solution for this, we know a is at least 1, x is at least 1, so that be some apples at least, and then we are through. Find some integer solution that satisfies this. We can plug that back in and then we are through. 960 is a multiple of 15, yet we get 960, to be very honest, multiplied by 10, 960, 2 by 5 into 10 is 4, 3 by 2 into 10 is 3 into 5, 15. Nice. So a cannot be If A were 0, this works. 960 is a multiple of 15, it's a multiple of 3, it's a multiple of 5. Now, 4A has to be a multiple of 15 in order for this to get satisfied. The smallest possible value is put A equal to 15, put A equal to 15, 960 plus 60 equals 15x. 960 by 15, let's do 64 plus 4 equals x, or x is 68. A is 15, 5x is 68 into 5, 340, that works. Nothing short of this will work. The smallest possible total number of fruits is 68 into 5, 340. Nice question. We have to keep our wits with us and say, okay, nice, I'm trying to find integer solution for this, such that A and x are as small as possible, particularly x is as small as possible, such that A, x are both natural numbers, integers greater than 0. Simplify that, we're through. Right? That's what we're looking to do here. A rectangle with the largest possible area is drawn inside a semicircle of radius 2 centimeters. Semicircle of radius 2 centimeters. Largest possible area from a rectangle like this. The ratio of lengths of the largest to the smallest side of this rectangle. So let's say, hey, this is x, this is x, this is y, this is the radius r. Semicircle of radius 2 centimeters, radius is r. We know that x square plus y square equal to r square. We want area to be maximum, or we want to maximize 2x into y. We maximize xy. X square plus r square is r square, x square plus y square is r square, that is fixed. Given x square plus y square, how do we get maximum value of xy? And so we know that x square plus y square by 2 is greater than or equal to 2 times root of x square y square, or x square plus y square greater than or equal to root of 2xy. X minus y whole square is greater than or equal to 0. Arithmetic mean is greater than or equal to geometric mean. We simplify, we get that. And they're equal. That's when the maximum xy happens when x is equal to y. This whole roundabout mechanism tells us that area will be maximum when x is equal to y. When will x is equal to y, or this is 2x, this is y, this is twice of this. Ratio of the largest to smallest side of this rectangle is 2:1. X square plus y square is a constant. What is the maximum value of xy? That will happen when x equal to y. Plonk in x equal to y, largest to smallest ratio is 2:1. A n equals 46 plus 8n, b n equals 98 plus 4n, two sequences for natural numbers n less than or equal to 100. Then the sum of all terms common to both the sequences. Right? A1 46 plus 8 54, A2 is 62, A3 is 70, and so on. B1 is 102, B2 is 106, B3 is 110, and so on. This goes in step size of 8, this goes in step size of 4. We have to find sum of all terms common to both of them, n less than or equal to 100. The 100th term here is 46 plus 800, 846. The 100th term here is 400 plus 98, 498. So the common part will get cut off here. I won't go beyond 498. And so this goes in steps of 8, that goes in steps of 4. So if there is one common term, there could be, there should be, given they have given us this question, then from then on, that number plus 8 will be part of the sequence. So I'm going to say, how do I find the common term? We have to go all the way till 102, 106, 110. I'm going to brute force it. 70, 78, 86, 94, 102, 110. 110 is there, 102 is there. So my new sequence, it's a common sequence, will start with 102. I'm going to say C1 is 102, C2 is 110, C3 is 118, C4 is 126, and so on. Till Cn, which could be 498. Could be, may not be. 498 need not be an element in this sequence. This goes step size of 8. This is 96 plus 6. This is 104 plus 6. So each number here is the form 8k plus 6. 498 is it of the form 8k plus 6. I'm going to take 498 divided by 8 or 6 times 48, 18, 2 times. No. It is 8k plus 2. So 498 will not be an element here. 494 will be. One term before. So B100 is not a part, B99 is a part. So 494 is there. How many elements are there in the sequence? This is the first term, 102 plus n minus 1 into 8 is 494. Or n minus 1 into 8 is 494 minus 102, which is 392. Or n minus 1 is 392 by 8, 32 gives us 4, which is 49, or n is 50. There are 50 terms common in this sequence, starting with 102, going all the way till 494. Sum of all those terms is 50 by 2 into 110 plus 494. Sum of all those terms, 102 plus 494, not 110. Or this is 50 by 2. I'm keeping it as 50 by 2, not taking it as 25. Add these two, 2 plus 4, 6, 9 sitting here, 596. So let's divide this first of all. 596, 600 by 2 is 300. This is 298. 50 into 298 or 100 into 149. Which is 14900. Hopefully that's there among our choices. It's there, done. The value of 1 plus 1 plus 1 by 3 times 1 by 4 plus 1 plus 1 by 3 plus 1 by 9 times 1 by 16 plus 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 times 1 by 64 and so on is tough one and a proper pain in the neck. We need to figure out a way. There's a GP inside which another progression is being tagged on. So 1 plus 1 by 3 is 4 by 3, 4 by 3 into 1 by 4, comes 1 by 3. 1 plus 1 by 3 plus 1 by 9, you have to figure that out, 9 plus 3 plus 1, 13 by 9 into 1 by 16. Not very friendly. I thought numbers will get cancelled and give us some very sweet thing. That is not happening. So what am I going to do? I'm going to say, hey, I'm going to take the first terms in this sequence. Attack them first. So first terms, that is 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 and so on infinitely. Then second term, 1 by 3 into 1 by 4 plus 1 by 3 into 1 by 16 plus 1 by 3 into 1 by 64 and so on. Next terms of the sequence, 1 by 9 into 1 by 16 plus 1 by 9 into 1 by 64 and so on. Nice. What I'm going to do, I'm going to treat this first one, that's a GP, infinite GP, with first term being 1 and common ratio being 1 by 4. I know how to plug this in. I'm going to think of this as sum 1, sum 2, sum 3 and so on. I'm going to first find out sum 1, not sum 1, sum 1, right? A by 1 minus R, 1 by 3 by 4, 1 minus 1 by 4, 1 by 3 by 4 is equal to 4 by 3. Nice. Next, what are we going to do? We're going to say, okay, nice, so far so good. Let's do sum 2. The first term is 1 by 12, 1 by 3 into 1 by 4, first term is 1 by 12. The common ratio is again 1 by 4. So 4, 16, 64. The 1 by 3 remains the same. 4 becomes 16, 16 becomes 64, 1 by 4. 1 by 12 by 3 by 4. 1 by 12 into 4 by 3 or 1 by 9. The next term, the first term is 1 by 9 into 1 by 16. Common ratio is again 1 by 4, by 3 by 4 and so on. Now if you notice, sum 2 we calculate in a very convoluted fashion. The common ratio is the same. The first term is 1 by 12. There is a 1 by 3 and a 1 by 4. Here the first term is this first term into 1 by 3 into 1 by 4. Or if you think about it, S1 is 4 by 3. S2 is 4 by 3 into 1 by 12. S3 is 4 by 3 into 1 by 12 into 1 by 12. This is again a geometric progression, again an infinite progression, again one with first term 4 by 3 and common ratio 1 by 12, or sum of this whole thing is 4 by 3 by 1 minus 1 by 12, 4 by 3 by 11 by 12, or 4 by 3 into 12 by 11, which is 16 by 11. Hopefully that's there among our choices. Yes, it's there, that's the right answer. Suppose f of x comma y is a real valued function such that f of 3x plus 2y comma 2x minus 5y is 19x. For all real numbers x and y, the value of x for which f of x comma 2x is 27 is pain. F of x comma 2x is 27. You have something to start with. This has two variables. This has only one. But remember, this one, the ratio of these two is 1:2. What I'm going to do, I'm going to just say, hey, this whole idea that f of x comma 2x is 27 works in the scenario there is some x and the second part of that is twice of that. I'm going to say this formula works beautifully, involves only x, and this comes to 27. I can manipulate everything in terms of x. If I can make this 1:2 condition satisfied here, I'm going to forget everything else and then say, hey, 3x plus 2y into 2 equals 2x minus 5y. If I can make this work, then this is of the time f of k comma 2k. Then I can substitute 19x, solve for this, get everything going. Right? Fine, convoluted method, but let's approach this. So 6x plus 4y equals 2x minus 5y. 4x equals minus 9y. X equals minus 9 by 4 times y. Y equals minus 4 by 9 times x. Nice. So what I'm going to take this and substitute this here. F of 3x plus 2 times minus 4 by 9x, comma 2x minus 5 times minus 4 by 9x equals 19x, or f of 3x minus 8 by 9x, 27 by 9x minus 8 by 9x, comma 18 by 9x plus 20 by 9x equals 19x, or f of 19 by 9x, comma 38 by 9x equals 19x. We know f of x comma 2x is 27. We know f of 19 by 9x comma 38 by 9x is 19x. We want to find f of x comma 2x equals 27. This ratio is 1:2, this ratio is 1:2. I'm going to say 19 by 9 comma 38 by 9x is 19x. What is the f of x comma 2x is 27. So I want this to be x, this to be 2x. I'm going to treat this slightly differently. I'm going to say f of 19 by 9, just to simplify this, 19 by 9k plus 38 by 9k is 19k. So treat it very differently. This into 2 is this. Suppose I put k as 9 by 19, 9x by 19. Hypothetically, 9x by 19. K is 9x by 19. Why am I doing this? Because I'll get f of x comma 2x. K is 9x by 19. So 9x by 19 into 9x by 19 to 9x by 19. So this goes away, this goes away, this goes away, this is 2, this goes away, 9x. We get f of x comma 2x is 9x. It's reframing that equation. F of x comma 2x is 9x. So this is 9x. 9x is equal to 27. X is 3. F of 3 comma 6 is 27. You plug it back here, this will be satisfied, this will be satisfied, all of that will be satisfied. Painful question, tough question, but doable. Super tough question, beguiling question. And so I found it really tough. Right? Rahul, Rakshita and Gurmeet working together would have taken more than 7 days to finish a job. On the other hand, Rahul and Gurmeet working together would have taken less than 15 days to finish a job. However, they all worked together for 6 days, followed by Rakshita, who worked alone for 3 more days to finish the job. I don't even get this. Fine, I had to write this down to even make sense of it. Rahul, Rakshita and Gurmeet put together greater than 7 days. Rahul and Gurmeet together fewer than 15 days. And I thought I could make some inference from here. It was greater than 7, less than 15, twice of 7 is 14. I thought this could work. But then, look, greater than 7 need not be 8, it could be 7.1. Fewer than 15 could be 14.8. So it's not more than twice. That relationship doesn't hold good. And so I thought they're taking more than 7, this take less than. This could make some inference about with the idea this is more than twice of that. There was something to go there, but it didn't happen, because if I could say minimum is 8, maximum is 14, then I can make an inference, but it's not true. This could be 7.1, this could be 14.9, so I couldn't draw any inference there. However, they all worked together for 6 days, followed by Rakshita, who worked alone for 3 more days to finish the job. If Rakshita had worked alone on the job, then the number of days she would have taken to finish the job cannot be. As it is, there are 2 inequalities type things. Right? And then Rahul and Gurmeet and Rakshita work for 6 days, and Rakshita alone works for 3 more days. Where does this go? Right? This question, but rather beautifully, gets unlocked if we make one simplifying assumption. Dealing with 3 people is tough, but it always dealing with Rakshita separately and Rahul and Gurmeet together. So what I'm going to do, instead of saying Rahul, Rakshita, Gurmeet, I'm going to take Rahul and Gurmeet together and call it some k. And this makes life dramatically easier, because now we can say k and r take more than 7 days. K takes less than 15 days. And then k, 6 days of k and 9 days of r finishes the task. Nice, interesting. So now let's say the task is t, some task t, and what k can do in a day is k is Rahul and Gurmeet together. So they take more than 7 days to finish it, or 7k plus 7r is less than the task. K can finish the task in 15 days, or 15k is more than the task. If k works for 15 days, he or she or them or that unit will finish more than the task. In fewer than 15 days, they finish the task. So 15k is greater than the task. We also know that 6k plus 9r is equal to the task. And the task is 6k plus 9r. All of them work for 6 days, and then Rakshita work for 3 more days, or Rakshita works for 9 days, Rahul and Gurmeet together work for 6 days. 6k plus 9r is equal to task. This task can be completed by this team, and 7k plus 7r does achieves less than the task. 15k achieves more than the task. Now I've got something going. What can I do here? I can say, hey, 7k plus 7r is less than 6k plus 9r, or k is less than, oopsie, this doesn't look like k, does it? K is less than 2r. 15k is greater than 6k plus 9r, or 9k is greater than 9r, or k is greater than r. It's nice because it says k sits between r and 2r. Oopsie. Now this is nice and simple. R we've got to do, 6k plus 9r is equal to t. K, smallest value it can take is little more than r. Highest value it can take is little less than 2r. I put r, I get one extreme. I'll get 2r, I'll get another extreme. So k is more than r. K were equal to r. 15r equal to t. K has to be more than this r. R has to work for more than 15 days to get this. Right? If I substitute the other way around, 12k plus 9r, 12r plus 9r, 21r equal to t. Both of these don't work because r less than k less than 2r. I'm just putting the extreme values to make sense of it. K could be 1.0001r, in which case it will be 15.006 r equal to t, 20.9999 r equal to t. Right? So, nice. So we can infer that 15r less than the task less than 21r, or the number of days r takes Rakshita is more than 15, at least slightly more than 15, and less than 21, at least slightly less than 21. Now we go to the choices and say, hey, it could be this, it could be this, it could be this, it cannot be this. This is the answer we're looking for. As I said, super tough, properly challenging you to frame the equation. The big takeaway for me from this was to look at this and go, look at these three things and then say, Rahul and Gurmeet are one unit. And then I have something to go with. If I had Rahul, Rakshita and Gurmeet, I'm going mad, which is what I did in the exam, and I skipped this question because there are three variables and two weird inequalities, one equation, and nothing I could do with it. This were 7 and 14, I would have done something with it. 7 and 15 is a pain. So I thought, not going anywhere, I skipped this question. But if I can think of Rahul and Gurmeet together, then I've got something going. Gautam and Suhani working together can finish a job in 20 days. If Gautam does only 60% of his usual work on a day, Suhani must do 150% of her usual work on that day to exactly make up for it. And so Gautam falls short by 40%. Suhani brings in 50% more. So 40% of Gautam is equal to 50% of Suhani. And so that's only 60% of his usual work. And he falls short by 40%. 40% fall of what Gautam can bring in, 40% of Gautam is offset by 50% of Suhani, or 4g is equal to 5s. This is what Gautam can do in a day. Mind you, not number of days Gautam takes. What Gautam can do in a day and what Suhani can do in a day. If you're comparing that, their efficiency, rate at which they create output, 4g equal to 5s. Nice. Together they can finish a task in 20 days. Both of them together can finish in 20 days. So we can say, hey, what does Gautam bring? Gautam brings 1.25 times what Suhani brings. So in each day they'll bring s plus 1.25s, 2.25s. This into 20 is the task. Or 2.25 into 20, or the task can be defined as 2.25 into 2 is 4.5 is equal to 45s. What Suhani can do in a day into 45 is the total task. then the number of days required by the faster worker to complete the task, or Suhani, takes 45 days to complete the task. Super. Suhani takes 45 days to complete the task. Gautam is the faster worker. Why so? Because Gautam does 1.25 times Suhani's output in a day. Faster worker. So Gautam is 1.25 Suhani. So Gautam will take 45 divided by 1.25, or 45 by 5 by 4 into 4 by 5. 36 days. Gautam is a faster worker. He is 25% more efficient than Suhani, or he'll take fewer days than Suhani. So Suhani takes 45 days, Gautam will take 36 days. The faster worker will take 36 days. Nice juicy question, should be knocking it off. Triangle ABC is an isosceles triangle such that AB and AC are of equal length. AD is the altitude from A on BC. B is the altitude from B on AC. Okay, nice. ABC, AB equal to AC. AD is the altitude from A on BC. Okay, nice. These two should be equal because it's an isosceles triangle congruent that we can prove. BE is the altitude from B on AC. So this is E, this is D. AD and BE intersect at O such that angle AOB is 105. This is O, AOB is 105 degrees. So this is 105. Then AD by BE is equal to, oh nice, this is 105. This should be 75. This is 75. This is 15. 90 degrees. This is 90. 75. This is 15. This is 15. This is 90. This should be 75. This is an isosceles triangle. This is 75. This should be 75. Two sides are equal. Two sides. So 75 plus 75 is 150. The whole thing should be 30. Angle BAC is 30 degrees. 75 plus 75 is 150. Overall angle is 30. So this is 15. This is 15. This angle is 60. 60 plus 15 is 75. 75, 75, 30 is the big triangle. 15, 90, 75 is this triangle. We want to find AD by BE. AD is this triangle, by BE is part of this triangle. AD is the altitude, BE is this. Okay, this is a pain. It's going to be tough. And how do we do this? We can use sine rule. I'm going to use sine rule for this triangle, or just use trigonometry for that triangle. Nothing more than that. We can get something linking AD and AC. We can get something linking BE and BC, and we can link BC and AC. Nice. That's what I'm going to do. AD and AC. AD by AC. AD by AC is opposite by hypotenuse for this is equal to sine 75. BE by BC. BE by BC. BE by BC. BE is here, BC is here, opposite by hypotenuse, again is sine 75. Or AD is AC sine 75, BE is BC sine 75. AD by BE is nothing but AC by BC. This is AC sine 75, this is BC sine 75. So we're looking at AC by BC. AC by BC, I can just plug in sine rule, I'm through. AC by sine 75 equals BC by sine 30. AC by BC is sine 75 by sine 30. Sine 30 is 1 by 2, or this is 2 sine 75. What we are looking for is 2 sine 75. It's not sine 15. Sine 75 is cos 15, that I know. It's not this, it's not this. It's 2 cos 15, we are through. 2 sine 75 is 2 cos 15. Sine 75 is cos 15, we are through with that. What are we doing here? We are writing AD by AC as sine 75. We are writing BE by BC as sine 75. opposite by hypotenuse. So AD by BE is what we want to find. AD is AC sin 75, BE is BC sin 75. AD by BE is AC by BC. Sin 75 gets cancelled. We need to get the ratio of AC to BC. AC, BC, sine rule. AC by sine of 75 is BC by sine of 30. A by sine A equals B by sine B equals C by sine C. AC by sine 75 equals BC by sine 30, or AC by BC, which is AD by BE, is sine 75 by sine 30. Sine 30 is 1 by 2, so it's 2 sine 75, which is 2 cos 15. Beautiful question, super challenging, tough question. You'll have to use some trigonometry and sine rule and manipulate a little bit and know that sine 75 is cos 15. Brilliant.